People welcome back.
We have the technology. Oh, we have the technology. All right.
You can make it an object eraser.
I can make what?
So like instead of it deletes the whole thing, so it's part.
Boom. All right. So they see it here. Oh yeah, we done goofed. All right. We're learning how technology works today at Pwn College or at ASU. Okay, so when we run, what we're doing here is we have the stack, we have RSP, which is pointing here, and then we have some gadget here and some gadget here, right? And we can think of the series of gadgets. We call this right here a ROP chain, right? Everyone understand how ROP works fundamentally? Cool. So what I talked about last week, Thursday, was pivoting, right? I showed how we could pivot this because in traditional ROP, we say that this is just the stack. And we overwrite it, and so it just pops off. We execute this every time that a gadget consists of do something like move RAX 20 followed by a rect. And we're like functionally limited by this idea. We're functionally limited on like where we can place our gadgets because all of our gadgets rely on ret. And ret is essentially pop RIP, right? And when we ran into scenarios where the stack was not a place that was conducive for us to place gadgets, we said, well, we can fix that. We can pivot our ROP chain to somewhere else. And we did that by essentially hopping into RSP, right? Whether it's by a literal pop RSP instruction or whether it was via this idea of pivoting. And we did that via leave and then ret. And we said that leave is essentially the same thing as doing, what is it, move. Boop, boop. Move RSP. Oh, you can't. Yes, you can see. Move RSP, RBP, and then pop RBP. And it turns out if we do that a couple times, we can set RBP, and then we call it a second. We set RBP with the first time, we call it a second time, and we then move that value to control RSP, right? Is ret the only like control flow mechanism that we have in a program? The answer is no, right? We can redirect control flow with call instructions. We can redirect control flow with jump instructions. We can redirect control flow with like a number of different things, depending upon how the program is structured. Now, I'm going to say younger sibling of this concept of ROP is the concept of JOP, which is jump-oriented programming. And if you go down like the field of exploitation, a little bit longer, definitely more than what we'll cover in this course, you'll find that there's a bunch of like X oriented programming. This concept of abusing existing functionality to create a weird machine is insanely prevalent. If you look up some of like the most advanced or like coolest exploits, I tried to find this. I looked for like not straight half day straight, but there's an exploit that I was trying to look up that I couldn't find, so I wanted to pull it up. Where it was a remote exploit. They exploited like the Chrome browser or whatever. And what they did inside of that was they created their own virtual machine. So if you're taking 355, you're taking 355 right now, you learn about like state machines, you learn about Turing machines, and you like learn about these like super simple primitives of like, can I increment a pointer? Can I set a value? Can I read a value, right? If I can do that, I have like most of the primitives I need to essentially build a modern computer. And I can't find the link, but what they did was they found a primitive that allowed them to increment a pointer and decrement a pointer and set a value. And they used that in like the fundamentals of theoretical computer science to build an entire computer off of these primitives as their exploit chain that could then they built a compiler that compiled to these little exploit primitives and built a functional Turing machine, and their exploit ran on their fake little Turing machine running inside the browser. It's super cool. That's why I can't believe I couldn't find it because it was one of the coolest like complex exploits. But this idea of weird machines is very prevalent. And so what I want you to like take away there is that ROP is not the end all be all, although ROP is very common. What I have here for our demo is something that, in theory, you won't ROP, but somebody probably will. It's the curse. The curse of writing challenges. I don't have it live in the demo dojo right now because I rewrote it this morning. And it is called just Drop Me. All right. Drop Me is not a particular crazy binary. It says, here's some random data, give me your random bytes, and then we're good. So the first thing that you may want to do as somebody that's looking at this is, and I would too, like I'm trying to open this thing up in IDA and let's see what's going. I actually don't know what this is going to look like in IDA. It's going to be fun. Boom, boom. We'll hit tab, the most important button in IDA. Okay, so this challenge is going to open the flag. It says, here's some random bytes. It opens dev random. It calls send file and gives us 4 bytes from dev random. It says, give me your random bytes. And it's going to read in some payload, and then it will return a value. Does anyone see anything crazy here? Yes.
So we read into V5 65th position.
So I don't know why this is saying this is an IDA-ism. It's saying that the return value from read is going into the 65th position of V5. What is the return value of read? Do you happen to know? It's the number of bytes read. And we can check the man page and it would tell us that. So this is an IDA-ism, which is probably because IDA doesn't have the correct type here for whatever V5 is. IDA thinks V5 is 66 bytes. What I will say here is
64 bytes? Maybe it's a jar.
IDA says it's 66, right? I would expect it to be less. At most, it could be, if we think about how the stack layout is, I'm surprised that IDA shows this because I know more about this binary than IDA does. But if RVP, if V5 is located at RVP minus hex 118, what happens if we write more than hex 118? We've overflowed the frame, right? Are we reading more than hex 118 here? Yes, we have. So we have, big surprise, a buffer overflow. So what do we want to do? Let's move. Do I have a do.py? We'll do it. We'll make our new do.py because we want to start poking at this thing. And I'm going to start poking at it with Python early. User bin end Python 3. From pwn import star, context arch. AMD 64. P equals process. What is this thing? Challenge job me. Okay. How do you want to poke at this thing? We know there's a buffer overflow. We know we can mess something up. Or at least we're pretty sure about that. Right?
Send a cyclic.
Send a cyclic. I love it, right? Like, that's much better than like semesters ago. It was send A's, right? We progressed. Payload is going to be, so we'll say cyclic, I don't know, 400, some big number. P send payload. And then P interactive. Okay. Read only. Not anymore. chmod plus x, do.py. We run our do.py. Okay. We did manage to seg fault. You see that up there? We returned xcode -11. So there's something a little bit interesting going on. But we sent a cyclic. How do we use this cyclic? There we go. We bust out the old gdb.debug. Give it one of those. We're going to set it free. And what we find here, how do I know how far into this it is? How do I use the cyclic value from the screen? Where does this, how does the cyclic value help me? I'm looking at what? The return value. Where is that on my screen? Okay, I don't know what info frame is going to do right here. Okay, so it does give me that right here. It was also at the top of the stack, which is what I was hoping people would hit me with. Remember, ret is essentially pop RIP. So the value at the top of the stack at the moment of ret is that value. Info frame's another valid way of getting it. Both go to the same place. I will look it up. It's 280 bytes in. For those that are unaware, in GDB and in Vim and in most interactive tools. If you start with an exclamation point, you can just execute a shell command, right? And so that's what I'm doing here. I'm using the shell version of cyclic lookup to find that value. It's 280. Cool. So what do you want to do? Based on what we talked about, you might think, okay, I can get there. It's 280. My payload is going to equal payload ljust, because I am someone who can see the future here. 280. What do we want to do? We can rob, right? Okay. What do you want to do? Something about shell code? I don't know. That's a new word. I'll take it. Like maybe I didn't officially look at checksec on this thing. Cool. We saw that there is no canary because we did make it to the saved return address. This is also no pi. So we can reason about where things are located. What you would probably say is, hey, I want a stack pivot, right? Last week we said, hey, let's do the stack pivot thing. We can overwrite saved RBP. We can throw a leave in there. Everything's going to be great. Let's see. I'll do a quick sanity check and show you why you can't do that. I think we break on main. I'm inside main. I'll step in a few instructions so that way I'm just like somewhere in this. If we were to info frame, if the dojo didn't betray me, it did not. What do you notice is not in the saved registers? Okay, so this, it turns out, and this is like a real thing. It's not a troll on you guys. There's a compiler flag. It's -f. No stack frame or no frame pointer. You can just compile a binary and not use RBP as a frame pointer. Like, cool. So if I don't have a saved RVP, can I do like pivoting shenanigans here? No, can't. So I got to be even more clever. There's some other functionality in this thing that I could abuse. I don't get a libc leak. I don't get a binary leak. I don't really need a binary leak though, right? Because I have this elf. So E equals elf. What is this thing? Challenge drop me. Just have that to have that. But we know we can overwrite saved rip. So maybe we're still clinging to this idea of ROP, right? Makes sense. It's a valid plan of attack on this. I have something. There are some gadgets that are useful here, right? We see some things, but like there's also a lot of like jumps in here. And I don't think there's a syscall. So maybe we want to consider some of these other parts of execution. So ROP gadget in particular, although many tools have a similar flag, allow you to search specifically, say, hey, don't show me ROP gadget, show me job gadgets, or show me calls, right? All of these things are interesting. And in fact, if you just run ROP gadget without any flag, it's showing you ROP gadgets and job gadgets and like anything that directs control flow that might be interesting. It might be useful. These aren't like exclusive techniques. They're things to just like consider and think about. What makes job interesting is we are now looking for instructions that end in jumps. But there's a problem here. A lot of jumps are functionally useless. Like, take this thing right here. It's going to do, I don't know, something, and then it's going to jump to a hard-coded address. What are the odds that that hard-coded address, like, can I influence that or control that? Like, no, it's hard-coded. Right? Maybe it jumps to some useful functionality in the binary, but odds are pretty good it doesn't. And so the type of gadgets that I'm interested in from job are things that end by jumping to their indirect jump, or they're jumping to a value in a register. Okay? Now, we still don't have the mental kind of picture for how job works or how to think about job, because with ROP, we have this nice, here's the stack, here's our gadgets, and we just and we move on. Job uses a similar idea, except there's a bit more going on. So when we were doing ROP, we said we have this ROP chain that's on the stack. When we JOP, we still have a region, and this region still contains gadgets. Except these are jump gadgets. But I need to somehow be able to replicate this idea of jumping and executing something and then incrementing a point, right? So what I need is some type of gadget that isn't xrect. I need something that is inc jump, right? I need something that increments a pointer and then indirectly calls it. This idea of a inc jump is called a dispatch gadget. This has the pattern of, it doesn't not necessarily inc. We'll say add, see if the technology works.
Rob, we can't see what you're writing. It's this side.
The technology, man. We aren't ready for it. Please let me know. We're going to say add, I'm going to use RDI. I will say 8. And then I want to either call or jump. Jump is preferable, but both would work in this case. I'm looking for like jump RDI, right? This is the kind of gadget that I'm looking for in a dispatch gadget. Now, this jump could be a call. This add RDI, this could be adding to a pointer in memory at RDI as long as I'm jumping to the memory address in RDI. So it doesn't need to be this specific form, but the point is there's some pointer. We are incrementing it by a value, and it doesn't even need to be 8. You can imagine that we have add RDI 16. This just means my gadgets need to be 16 bytes apart somewhere in memory, right? So I need to have there needs to be a dispatch gadget, and the dispatch gadget determines what register I need to set and the stride for where I'm laying out in memory. Because my goal is to replicate this mechanism of what we had here in ROM. Oh yeah, when I move it on the tablet, you don't see it here. I want to replicate something like this, right? Where we have this like ret and just kind of popping off of the stack. But I have to do that using a specialized dispatch gadget if we're thinking about Java. So let's see. We take that, we'll say dash dash no ROP, and we'll grep it for, just look for jumps. Do we see anything on here that looks anything like that? Okay, so yeah, there's something like that. I'll go with that. I don't know that that's. Which one did you see?
Oh, there's an ad that RSI and jump keyword pointer at where RSI is pointing.
Okay. This guy right here.
Two below.
Two below it. Add RSI 8, jump keyword pointer RSI. Yeah, that is a yeah. They should be the same. Does that truncate? I don't know if that truncates or not. But this one definitely won't. So I have that pattern right here in add RSI 8, jump keyword pointer RSI, and it's at this address here. So I have something I'm interested in. Where is it? See if I can copy it. Boop, boop, boop. This value right here. Boop. And we're going to say our dispatch gadget is that value right there. Now let's make sure we can get there. We will payload plus equals a P64 of our dispatch gadget. Okay, I'm going to conveniently set a breakpoint at that exact same spot since it's on my clipboard. Hopefully we get there. We did not get there. Because we are still returning to a cyclic value. Why am I doing that? Oh, that's because I made this. Payload is going to be A. We're going to adjust it to 280 with B's. Then we have our gadget. Okay, I did get there. The question now is, what is RSI? Now, this challenge is somewhat contrived, but we do see in this scenario, this is what? What do we notice about the value that's located in RSI?
First up.
It looks very much like our payload, right? I started my payload, if we check the script, with an A followed by a bunch of B's. What we see right here, here's my A, here's a bunch of B's. Now, part of me reworking this was on my dev box when I was writing this. Inside of IDA, my version of glibc, which is different than the Dojo's, when it calls read, it leaves RSI where it is, which is why it happens to work. On the Dojo, it's slightly different, and so I had to add some trickery. But the point is that it can naturally be there, right? In this scenario, if you take it at face value. Okay, so I have a dispatch gadget, and we know RSI can point to you see this, we have the dispatch gadget. It can point to this spot right here. So what kind of gadgets do I want here? Do I want things that ret?
What if we don't have, like, let's say your shadow stack or anything is enabled.
I'm sorry?
If like a shadow stack or anything is enabled by some chance, then Drake won't work.
So the statement is what happens if, which we haven't talked about officially in this class, but there is functionality that is known as a shadow stack, which is one of the other outputs that you can get from checksec here. Apparently this one doesn't show it. I don't know why that is the case, but there is another mitigation strategy that's known as a shadow stack. In that implementation, every time that you call, in addition to pushing the saved return value onto the literal stack that you have in userland, it is also pushed to a shadow stack, hence the name, that is located in a region of memory that you cannot access from userland. If there were a shadow stack, then this would not work because we would not be able to do that initial pivot via that first return. Now, if I somehow manage to redirect control flow to my dispatch gadget via something other than ROP, and the reason that I'm using ROP is because that's what the class knows right now. Like, we could go into like insanely complicated things, but it's not worth going down that road. And so I'm trying to stick to primitives and things that we have already covered. But the jumping part would work. If I jump somewhere, a shadow stack doesn't prevent that. A shadow stack only cares about when we call and when we ret, when we're pushing return addresses and returning to them. So if we ignore the initial ROP, that one gadget ROP that I'm doing, the rest of this would work in the face of a shadow stack. But it is something to consider for sure. So we're trying to build some weird machine that does this, right? We have our dispatch gadget that needs to call into, or it's going to jump into a gadget here. What does a jump gadget look like? What do you think? ROP gadget knows. So what kind of gadgets is ROP gadget giving me? When I run this bad boy. I said that these gadgets that we're interested in are generally of the form do something and then jump to a register or a region of memory that in theory we can control. I don't know that I can control R10 yet, but this is now a lofty goal, right? Like, all right, well, if I can control R10, then I could jump to this location, pop our RDX, and then if I control R10, I could send this back somewhere. Now you would think, and this is where JOP gets funky, is you would think maybe if I can set the jump target, what I want to do is I have this dispatch gadget, and then I jump to the next gadget, and I jump to the next gadget. I'm going to do something like this. This doesn't really work. And the reason for that is the gadgets that you have are super small, right? When I look at this like jump R10 gadget here, what are the odds that every gadget is going to let me set R10 and then jump to R10? Virtually zero, right? I'm asking for magic gadgets that would never let me do what I want. So instead, what we want to do is we want to make this R10, which looks like it's consistently a jump target, a constant. If we set it once, then we're good to go. Where would I want to set it to? I don't want to do this, because this means I have to constantly change it. What I want to do is I want all of my destinations here, I want R10 to be the dispatch gadget. What this means is every time that I execute my dispatch gadget, it jumps to we're going to call them like functional gadgets, right? Something that actually has an effect I care about. It is then going to jump to R10, which goes to my dispatch gadget, and the dispatch gadget is what increments my count. And so it's very similar to ROP in the sense that, yes, I still have a bunch of gadgets located in memory. Yes, they are in some contiguous order here, but I don't have the convenience of RET, where RET is doing two things in ROP. It is popping off and changing control flow. So in order to do job, I need to build a more complicated machine that's pulling off these same actions. My dispatch gadget is going to increment my pointer. It is doing the effect of like RET. It's incrementing my pointer and jumping there. Now all of these gadgets need to return back to my dispatch gadget to then increment to the next gadget, execute, and jump back. And so now we're starting to build within jumps our own weird type of execution. Yes.
So every gadget needs to jump to R10.
So the question is a good question. The question is, does every gadget need to jump to R10? The answer is no. In a happy scenario, the answer is, yeah, it'd be great, right? If everything ended in jump R10, then I could just set R10 and rock and roll. But if we were to look at the gadgets that are in here, they don't all end in jump R10. Some of them jump in RSI, some of them jump to, I don't know, probably RAX. RAX is pretty common. Jump to RAX. And so what we now have here is a series of constraints, right? What register can I control for and use as that return address for a particular gadget? And can I leverage one gadget, one jump gadget early in my chain to like push and then pop into another? So imagine that my first gadget set R10, right? Somehow I can control R10, which we can. Utilize the technology. These gadgets here, they rely on R10. While I'm doing this, boop, 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 life is good, we're relying on R10. What work might I want to accomplish in my work utilizing R10? I might want to set RSI, because maybe these gadgets, they rely on RSI. And so my strategy also becomes much more complicated. I'm going to leverage gadgets that use R10 to accomplish something I want, and then also leverage these to set RSI, jump to here, and then increment to gadgets that end in RSI. And you are correct in the sense that in a perfect world, before I even start any of this, I could set all of these to some constant and it would just go. In practice, I probably need RSI, right? Like RSI is a pretty commonly used register. And so you have to be methodical in what is the return jump register, right? To get back to your dispatch gadget, and consider that when selecting gadgets. Now, my claim here was that we could set R10. And that's because I wrote the challenge, and I happen to know that is just true. If we were to run our friend UDB on here, an info func, I conveniently named a function dispatch. And if we were to take a look at what is in dispatch, it not only has that add RSI that we saw, but ROP Gadget didn't tell me, hey, you can also do this, did it? ROP Gadget just showed me this.
That was there.
This was the top R10?
R10 set.
In the ROP train?
Yeah, we go.
Right there. Bam. All right. Generally speaking, these tools are bad at finding jump gadgets. And so you end up having to look at the actual assembly, like or object dump, to see what's going on. It did good this time though. All right, so maybe I don't want to go to this dispatch gadget. I want to go to, this is just the beginning of dispatch. So let's instead say payload, let's leverage our elf, plus equals p64 of e.symbols dispatch. So that's going to jump to the beginning of the dispatch function, where this right here is my dispatch gadget, which I'm not needing. So then what's the next thing I probably want to include on here is whatever I want R10 to be. What do I want R10 to be? Should it be dispatch, beginning of the function, or my dispatch gadget? For context, this is the beginning of my dispatch function. This is the beginning of my dispatch gadget. I'm jumping initially to pop R10 and set. Do I need to set R10 again? No. Once R10 is set, I want to just utilize this as a increment of pointer and jump there. I'm sorry? What is?
Oh, it's the value of R10.
Right, and so this is where it gets a little bit like messy as far as the names. There's right here, this E symbols dispatch. This is overwriting the return address. Right? And so I get a little bit of extra space after I do that in my buffer over. What I'm going to put there is my dispatch gadget. Why? Because the first thing of the dispatch function that I'm calling there in E symbols is pop R10. So the next thing that I place on the stack, which in this case is my dispatch gadget, will be popped into R10. The reason that I need it to be in, I need the gadget to be in R10 is because that means that I can now utilize jump gadgets that leverage R10, and I know they will come back to the dispatch. Does that check out? So since I have the ability to set R10 here, right, this is getting popped into R10. The next thing I want to do is I want to start actually building my job chain, because I haven't done that. But what do I want to do?
Another question.
Please.
So the gadget is it's jumping to RSI, right? Or RSI plus. Well, it's adding jumping to RSI, right?
Help me.
That's the gadget. Right?
Yes.
So
Why do I care about R10 if this is jumping to RSI?
no. How do you know it's jumping to the start of your buffer?
Because I looked at it in GDP.
Okay.
It just happened to be that case, very similar to like, did you do the very last shellcoding challenge by chance? It was like a 6 byte or,
Yeah, I did that.
right? And what was the trick then?
Oh, there was registers that were already set.
Right, registers have values just
Okay.
by nature of having values.
I see.
And so in this instance,
So fortunate.
our RSI, yes, because I'm hand waving a bit here, but because this main function, the last thing it does is read. I'm going to hand wave. I'm kind of lying to you here. RSI is going to be that value because it hasn't been changed since.
Right. Yeah. I see.
Right. And so we're abusing the fact that the last thing that happens is read, which means RSI should be primed with that value. It's just that living off of the land idea. Right. I 100% acknowledge that. Okay. Yeah, that's like a little bit of magic. And why are you doing that? Well, it's because I want to try and make it easier to understand, believe it or not, rather than harder. And so right here, we're just like, yeah, RSI is magically there by virtue of this recall. So I can set R10, and now I want to start building out this job chain. building out this. But my question is, at a high level, how the heck am I getting the flag? We still haven't really figured that out. We just identified like our initial column. What is your plan of attack based upon this? What would you like to do?
We reuse open and send file as
I'm sorry?
maybe we use open and send file and replace slash dev driver with flag.
Okay, so we're thinking about the right parts. The statement was maybe we can reuse open and send file and get the flag. It is a contrived and useless thing that this challenge is opening the flag by default, but that's because I wanted to make this drop chain hopefully obtainable in the time span of the class. We'll see if we actually get that. The challenge is already opening the flag. So we have file descriptor. What file descriptor would you bet is the flag here?
3.
3. Cool. So we'll say file descriptor 3 just is the flag. We can reuse existing functionality in the binary, such as send file, to just get the flag out to our screen. How do you want to reuse the functionality of send file? It is the right approach, or it is the intended approach, but there's one word that I'm like looking for. How do I trigger send file with different arguments?
We have control. We need to control RSI as well. I mean, we change the file descriptor RSI to 3 and then jump to send file.
That's interesting. Now, if we were to do that, we would get how many bytes of flag?
We need to change that up. It's not the RCX or it's R2.
That one would be our CX. That's interesting. That's not what I intended. You might be able to do it. What's another way that we could trigger send file? Because your initial thought, and it's a good thought, like it might actually be doable, is to jump somewhere in here. We'd have to, no, we'd have to jump here. So we'd have to set everything else. What's another way we could trigger send file? I'm sorry?
God.
So that the GOT or the PLT, yeah, we could jump into either of those. And so there's 3 different ways we could trigger send file. If the GOT's loaded, which we know it is at this point, we could call the pointer that is in the GOT. If we don't have that dereference, we can use the PLT entry. Both of those are contiguous with the binary, so that's good. And then lastly, we could reuse the functionality in the binary itself, which I didn't consider, but probably would work. All right, so now we have a goal, right? Our plan is to call send file. What do I want? 1, 3, 0, big number. So now I need to have some functional gadgets. All right, I want to set, what's our first thing? Set RDI. Do I have a RDI in here? I do. What do I have?
EDI. So it's somewhere.
You said EDI?
Yeah.
I got move EDI 0. So I only need it to be 1, and I see there's an ink, right? So this goes back to kind of that shellcoding golfing idea. I have this thing here, which is, I'm going to call it 0 RDI. I have ink RDI, which is this thing here. I don't think, because we had a pretty lengthy pre-stream ramble, I don't think I'm going to be able to finish all of this. We'll see. I'll try. Now, if I have my functional gadgets, what did I say needs to happen in between each of these functional gadgets? I need to jump back to my dispatch gadget, right? So how should I structure my payload? Right now, we're going to ret to this thing. We have our dispatch gadget. Where do the functional gadgets go in this payload? It's just like ROP and I put them at the end of my payload. And we just keep popping them off. The answer is no. The thing that determines where these gadgets need to live is the dispatch gadget. What did that thing look like? So it's going to be wherever RSI was, right? This is where the gadgets are that are being jumped to. Where was RSI? Just magically, we said it was at the beginning of my payload.
So jumping to the stack.
The question is so it's jumping to the stack? No.
So it should be at the beginning of the payload.
Yes.
But the payload's on the stack.
The payload is on the stack, but are we putting assembly instructions on the stack? What are we actually writing on the stack?
Address.
Okay.
But it seems like you're jumping. So,
I'm not jumping there. I'll set this up and we'll step through it and we'll see where we're actually jumping and how the gadgets relate. Yeah, the statement, so it's dereferencing RSI. That's what we see right here. RSI points to our buffer. We're going to dereference the thing that's on the stack and then jump to the address that's written there in memory.
That's what I was gonna say.
Cool. Yeah, it's the same idea as like ROP. ROP, we aren't executing the stack.
Right.
We are dereferencing RSP and jumping to the address that is there. We're just doing it in this nicely packaged thing that we refer to as route. Right? It's a very similar idea. We're just adding another layer of like messiness to this instead of having this like super clean ret instruction. Now let's see if I can write valid Python. Put these gadgets up here. I'm going to join, what do I want? P64 of X for X in functional gadgets. I want to believe that'll work. It might not, but we'll find out together since the GDB is there. Boom. Zero RDI is not defined. Okay, I'm gonna disassemble main. Right. Set the breakpoint at main plus 152. Get there. This is my one ROP gadget that gets me to my dispatch gadget. This is now popping R10, which R10 we see is dispatch plus 2. So the value that's being popped in is 1158, which is this right here, which is, I want this to fire off and call my functional gadget, which will then call R10, and we're popping R10 to be that 401158. So we're building like this loop, right? I'm going to call you, you're going to call back into me. They're not calls, they're jumps, but boop. All right, we increment the pointer, and let's just examine like 4 addresses at RSI. We did something funky here. Boop. All right, I'm going to jump. I'm now in inc RDI.
To have an 8-byte gap because first we are incrementing RSI and then here.
Yes. So very similar to what we saw with like leave, since my dispatch gadget is in this case inc 8 and then jump, I actually don't want to start my payload right at RSI. I want to put it 8 bytes in. Because right now I'm inking RDI and RDI, it happens to be 0. But I want to set it to 0 to be sure. Okay. Let's see if we can find another gadget, because we want to set what? RD, RDI, RSI? I want RSI to be 3. What can I do with RSI here?
What if we set RSI at the complete end?
Okay, so this is an intended subproblem when I designed this, right? Is we need to set RSI, but what is our pointer here that we're using to increment and dereference this whole thing? RSI. So yeah, we probably want to wait and deal with RSI at the end because it's the very last thing that we need to do, right? So what else do we need to set up? RSI, RDX. What does RDX need to be? 0?
0.
Okay, let's just see.
It will be 0 because read call keeps as it is.
Let's see. All right, so we are here. Let's info reg, see what we got. What was I interested in?
REX.
What is it? It happens to be 0. Okay. Then what's the last thing I need to do then?
RCX.
Okay. RCX. It's RCX because we are calling into libc. If we were doing a raw syscall, it would be what register? R10.
Yeah.
Weird, like, thing you just learn the hard way. Syscalls are slightly different when it comes to that register. So I need to set RCX. I have some kind of gadget right here that is add RCX hex 14 and then a jump R10. That's convenient. Let's just do a couple of these. So it's some big number. All right, so now we have the RSI problem. We got to be clever here, right?
We can use the pop RSI gadget and like what we do is we jump to RSI, it pops and then we update the address. Like
When do I update R10? You're thinking about it the right way, right? Our problem is if I update RSI and it is going to jump to R10, I'm going to come back to my dispatch gadget, and my dispatch gadget is going to jump to RSI. So I need to make sure when I execute the gadget that sets RSI, I don't come back to my dispatch gadget.
Yep. So in the last instruction that we jump to the dispatch gadget, we set a different value for pop RTN. So pop RTN will jump to send file.
Okay. How do you intend on setting R10?
The pop RTN.
The pop R10 that we already have?
Yep.
Okay. So right here, what we want to do then is we want to add the address of dispatch, which would be the dispatch function. Okay, what do we want to set R10 to be?
Address of send file.
Okay. How do we want to get that? I'll just tell you. You can get to the PLT, very similar to the GOT, and this will get to the PLT entry. So this is the safer way, rather than calling the GOT. Because if the GOT is not set and you jump to it, you get shenanigans. This will set it and get there either way because it'll call the resolver and do it. So I'd rather jump to the PLT than do GOT shenanigans here. Okay, then I want to do RSI. I didn't get my RSI gadget. What do we need RSI to be? RDI, RSI 3. Okay. Only thing I see is this pop RSI jump 10.
So we can have pop RSI, I mean 3 on the start.
But this, okay, so this doesn't go here then, does it? Because this is going to pop from the stack. Where's the stack? Is the stack in my payload?
Yes,
It's at the end of the payload, not here at the beginning of my payload. So I need to put this over here at the end. And then you want 3. So P64 of 3.
Yeah.
And then I need my pop RSI.
Oh, nice.
I'm sorry?
This is a typo.
Pip. This is not what I intended. We're like getting there, but I don't know if we have enough space on the stack. Find out. Boop. EPLT send file. Oh. This is a number, that is a number. What is it grumpy about?
Symbols dot address and then symbols dispatch dot address.
You want a P6 for the send file field.
I do or do not.
No, P6.
It is getting P64 down here in this comprehension.
At the symbol at the moment, but you just
No, it's not. The PLP's at the end of your payload.
Oh, yeah. This guy. There we go. All right. Okay. We have our breakpoint. We fire. Do some magic here. Where am I? That's a gadget. It's a moving. There's a jump back to my dispatch. I'm in my dispatch, which increments a pointer. Goes to the next gadget. There's my next gadget. We're incrementing RDI. That is my dispatcher. Jumping to the next gadget. I'm in my next gadget. That is making RCX big, which jumps back to my dispatcher. My dispatcher increments the pointer, jumps to the next gadget. The gadget is going to increment or increase RCX. The gadget returns to my dispatcher. My dispatcher increments the pointer. I then jump to the next thing. Hopefully you're seeing the pattern here, right? And it's just like, yeah, all right, I get it. But like when you first look at it or like read the paper on JOP, it just sounds insane. And so like going through this monotony hopefully makes it look a little bit less magical. We're back to our dispatcher. Our dispatcher is going to jump somewhere. We're popping R10. Okay, so we're setting R10 to be send file. That looks good. We increment our pointer. We jump to whatever is at RSI. It's going to pop RSI, and then it's going to jump to what was in R10, which is now send file. I am now in send file. Let's sanity check. I could have just set the breakpoint, but it's way more fun to say it. Let's double check our registers here, make sure that we have what we want. RDI is 1, that's standard out. Print RSI, that is 3, that should be the flag. RDX is the offset, which should be 0. We'll print our CX, which should be our count, which is some big number. Of course, it's going to fail and seg fault, but that's because I'm in GDB, so we couldn't open the flag to begin with. However, I am a believer, and we got our flag. We discovered JOP by just thinking about how all of this works. Yes, there were some contrived parts, but hopefully you understand the mechanics of it. This is all for your own amusement. JOP will not be on the exam. It will not be any of the graded stuff. It is just an example of another way that we can abuse functionality or control flow in a program to kind of create this weird machine, because that type of abstract thinking is fundamental to driving control flow where you want in weird scenarios. Questions, comments, concerns?
What was the intended way?
It was the same way. I just didn't. I expected you to not have enough space on the stack to just put your 3 and pop it, and instead to have to do it in the job chain, this ink push pop.
Oh.
But as I was like frantically trying to make this work on the dojo instead of my dev box, one of the things that I did was like, oh, you just get more stack space, because I had like 20 minutes maybe to try and figure out why the demo was behaving differently on the dojo instead of my local hardware.
So we did have an increment RSI.
So no, you didn't have an ink RSI. You still had ink RDI, but there was a push RDI and a pop RSI. And so the job chain would have then been 0 RDI, ink, push, and you'd have to have some reasoning about what you're pushing and popping to the stack, which would then influence the order of the gadgets, especially since RSI then needs to be popped off. Right. But ultimately we got where we wanted to. Like it was the same flow, just a slightly different tweak. It was cool to see, and I'm also curious to see if you could call into the binary, but we are over on time. I think it would work.
Yeah.
Like at a bare minimum, you could call into the call in main.
Most of the challenges in the rock module we've done, like calling it again and again.
That's a you thing, right? Right? Like I can't save students from themselves. We'll double check Twitch. Twitch is just chilling. I like it. All right. Goodbye. Good luck. Heap stuff goes live tomorrow. Nothing's really changing. I'm just naming things something fun. All right. Cool.